Hey everyone, welcome back to Science by Asha Mathpal. Today I will be starting up with the class 9th syllabus and I will be starting up with matter in our surrounding. It is chapter 1 in class 9th NCERT textbook CBSE Board. But before I start my session, I would like to request you all to kindly subscribe to my channel and share its link among your friends and family. So let's begin today's session. Now, matter in our surrounding, it is basically a chemistry chapter in which we will try to understand the matter around us. Now, if I ask you to list out the things which are present in your surrounding, some of you will say that there is a table, some of you will say there is a chair, there is a pen, there is fan, there is TV, right? If you are outside, you will say that there are trees, there is a car, there is a stone, there is water, right? What is common in all of them? They are basically having mass to them and there is some volume to them, right? Now, nowadays, scientists call all of these things or the materials around us as matter. But since ancient time, people have always tried to know more about the materials which are present around us. This quest has actually led to the matter and its various forms. So in this chapter, we are going to understand the matter, its physical state specifically. So matter is what? Matter is anything which occupies space and have got mass to it. Anything which is present in our surrounding which has got some mass and it is occupying space, they all will be put under the term matter. The matter, to make the study of the matter easier, the matter is studied under two main properties. One is the physical property, another one is the chemical property. The physical property, if we classify matter on the basis of physical property, it is solid, liquid or gas. So in this chapter 1, we are going to specifically understand about the matter, the physical matter forms, that is the solid, liquid and gas. In chapter 2, you will be able to understand the chemical nature, that is element, compound and mixture, right? So to understand the thing around us, this quest has led to the term matter basically, and matter is a very modern term. Like since the ancient time or the earlier times, in the Indian philosophers used to say that the materials or the things around us are basically made up of the 5 elements. That is, they are made up of panch tattva, that is air, water, sky, earth, and these things together make up, and of course fire was also there. So that was the panch tattva. But matter which is present in our surrounding is nowadays defined as anything which is occupying space and have got mass. That thing is called as matter. So let's begin with the physical nature. The physical nature of matter. The physical nature of matter, if we observe matter, the matter is made up of particles. How we can confirm this? For example, when you are about to enter in a desert, I am saying about to enter and not inside the desert. From some distance, you will see that the portion of the desert, I am drawing a very small portion, right? So you will be seeing that it is very smooth from some distance. It appears to be very, very smooth to us. But once you enter inside it, you will be seeing that it is made up of very, very small particles. Right, it is made up of very, very small particles. So in the same manner, it is said that whatever things which we are seeing, for example, pen, chalk, eraser, pencil, book, notebook, newspaper, all these things, when they are observed under a microscope, you will be seeing that it is made up of very, very small particles. Even a small drop of water, if it is observed under the microscope, you will be seeing that it is made up of millions and millions of the particles. Okay, so every matter which is occupying, that is space and have got mass, is actually made up of very, very small particles. From the surface, it might look smooth. That particular item, material or thing might look smooth to you, but if we are going to observe it under the microscope, we will be seeing that no, it is not smooth. It is made up of various small particles, very small particles. Now the particles are very small in size. How can we say that they are made up of or these particles which are made up of matter, they are very small in size? For that you can do a very simple experiment. In a beaker you can take, let us say, 10 ml of water, 10 ml of water. To it add 1 or 2 crystal. This is enough for 10 ml crystals of potassium permanganate, KMnO4, and mix it You will be seeing that it will get a very bright purple color, or a very magenta color, you can say it will come. Okay, pink color will be there, bright pink, magenta kind of pink color will be there. Okay, now take another beaker, in this beaker take 9 ml of water. Okay, and to this add 1 ml from beaker 1. This is beaker 1, right? Now if you will mix it again, it will turn pink in color. It will be pink in color again. The water, after adding the 1 ml water from the beaker 1, will be pink in color. This was bright pink, this is pink. Now if you will keep on doing the same thing with an assembly of even 10 beakers, let us say this is third, this is the fourth one, the same thing you will have to repeat. That is, in every beaker there is 9 ml of water. This 9 ml of water, and to this water you are adding 1 ml from the previous beaker. You will see that the pink color is still there. The pink color will still there. Although the brightness of the pink will keep on getting decreased. The brightness will be low, but the overall color will be pink again. So you will be seeing that in the beginning we are adding only 1 or 2 crystals of the potassium permanganate, and we have mixed it in 10 ml of water. So it has given us a very bright pink color. But when we have taken 1 spoon from this beaker and then we are adding it to the second one, the brightness got decreased, but it is still pink in color. If you do it with the 3, 4, 5, 6, 7, 8, 9, 10 and so on beaker, you will be finding that in every beaker the color of the water is still pink, although the brightness will be less. So you can imagine that how small these particles are there, that even 1-2 crystals of potassium permanganate are able to give so much of color. After so much of dilution also you are getting the same, the pink color is still there, not that brightness of course, but the pink color is still there after so much of dilution, and you have added only 1 or 2 crystals of the potassium permanganate, remember. So it means what? The single crystal of potassium permanganate is made up of very small particles, and these small particles were able to give so much of color in the respective or in the other beakers. Right, so basically matter is made up of particle, and these particles are very small in size. Now let us go to the next topic, that is the characteristics of the particles of matter. So we have understood that suppose this is a matter, it is made up of particles, right? It is made up of particles, and these particles are very small in size. Particles, and they are very small in size. Right, now we will be now trying to understand about these particles now. So particle of matter have spaces between them. How we can confirm that these particles are having spaces between them? For that there is a very simple experiment. In a beaker, take some water but mark the level of the water. Okay, let us say this was the mark of water here. To this water add half spoon half teaspoon of salt, okay, half teaspoon of salt, and mix it. You will be seeing that the level of the water will not rise. The level of the water will not rise. So where this half teaspoon of salt is going? Now in step 2, add more of salt. Okay, again mix it. You will be seeing that the level of the water is still the same. Again add more of salt. You will be seeing that still the level of the water is same. So where this salt is going? This salt is of course present in water here, but if there are no spaces among the water particles, then the level of the water should rise, isn't it? But even after adding 3 times, you are seeing that still the level of the water is same. So it means what? This beaker, which was having the water in it up to this mark, is obviously having water, and the water is having what? Particles to it, because we have understood that every matter is made up of particles. So these are the particles of water, these small circle, but there must be some space between them. That is why the salt is getting disappeared, and this salt is also having the particles and these particles are having some spaces between them. So when you are adding the salt to it, it must be occupying spaces between the particles like this. So it is getting adjusted, the salt is getting adjusted among the particles of water, right? Clear? So this experiment, this simple activity proves us that yes, the particles of matter have got spaces between them. Now next, the particle of matter are continuously moving. We are saying that these particles which are present inside any matter, they are in motion. These particles are in motion. Now how can we confirm it? For that we can take very simple experiments, and some of you might have observed it in your home also. Let us start with the incense stick. Incense stick. Incense stick is what? It is agarbatti. You all have seen. Okay, agarbatti, you all are aware of it. Now if we put a burning incense stick, if you are putting a burning incense stick in one corner of the room, after some time you can smell the fragrance even outside your house, right? Not even to the other room, even to outside of your house also you can smell the incense stick, right? Yes or no? So if you are able to smell, then it means obviously that the particles can travel from that particular corner of the room. From that particular corner of the room, the particles are able to travel to the various places, that is into their surroundings, and that is why they are spreading the fragrance of the incense stick. Okay, so this simple activity proves us that yes, the particles are in motion. Okay, although the level of the motion can be different, that in some cases we see that very high is there, in some cases it is very less, in some cases it is very negligible, but that thing we will understand in our next topic. Right now we are just understanding that whether they are in motion or not. Yes, they are in motion, because when we are putting an incense stick in one corner of a room, we can smell the incense stick even into the other room of the house, even outside the house also we can smell it. Okay, another experiment you can take that in a beaker, you can take water, and to this water you can add ink. Now when you are adding ink, you will be seeing that ink is going like this, okay, at a particular place, but after some time you will be seeing that the ink will change the color of the water. You have not mixed it, you have only dropped the ink inside the water, but after some time you will be seeing that the whole water has taken up the color of the ink, proving again that yes, the particles of matter are in motion, they move. That is why they got mixed itself inside the water. Not only the ink particles but also the particles of water are in motion. That is why they are able to mix together and they change the color of the water. Okay, so these are the two characteristics. The particles of the matter have spaces between them. That is, yes, the particles have got space between them. And second, the particles of matter are continuously moving. Now there is the third property also, that is the characteristics. In the characteristics, that is, the particles of matter attract each other. Okay, now see, the particles are there inside any matter, whether it is solid, liquid or gas. Okay, but yes, they are having a force of attraction between them. There is a force of attraction which exists between these particles. Okay, suppose this is particle A, B, C, D, E. Okay, so they will experience a force of attraction between them. Okay, so and this force of attraction helps them to bind with each other. This is the force of attraction which also helps them to stay together, whether it is any form of matter, solid, liquid or gas. So yes, of course, there is some force of attraction between these particles which makes them to stay together. Clear? And we just say them as the force of attraction among the particles. So let us start with the physical states of matter. Now in the physical state of matter, basically there are three states. There is a solid, liquid and gas. And why there is a variation, it is all because of the characteristics of the particle of matter. That is the size and the spaces among them, and of course the force of attraction between the particles. So let us start with the solid state. Now solid state, if you take like if I ask you that give an example of the things around us which are in the solid state, you can say that we have an example of pen, pencil, notebook. Okay, so these are all what they are in the solid state. Now you can keep these examples in your mind and you can write about the solid state, and you can also think on your own that what can be the possible characteristics of the solid state of matter. Okay, now if you take, for example, I'm taking a very small piece of iron here. This is an iron piece. Okay, now if you observe this iron and I say you to write about its characteristic, what you can say? You can say that yes, it has got a definite shape. The shape is defined because it has proper boundaries to it. The boundaries are clear cut here in the example. In any of the example of solid, there is a clear cut boundary which gives it a proper shape, or you can say a distinct boundary is there. And they have got a fixed volume. They have got a fixed volume, that is their volume is fixed. Okay, then they are having negligible compressibility. That is, if you try to push it, if you try to push an iron, the iron will not bend itself as such, remember. So they have got very less compressibility. You cannot compress them easily. Okay, the particles are very tightly packed. Now we have understood from the previous topic that every matter is made up of particles. Now in this iron, if you observe, of course the iron is also made up of particles. So inside it there are particles. But in the solid state, the particles are very closely packed. They are very closely packed like this. Suppose this is the iron piece, and inside this iron piece we will be seeing that the particles are very closely packed like this. So you are seeing that the particles are so closely packed with each other, like if I'm drawing here like this. Okay, so you are seeing that in between the particles, this is the space, this is the space, this is the space, this is the space, right? So the spaces are very less. These spaces are called as voids or interparticular spaces also we say them. Interparticle spaces. or we also say them as intermolecular spaces. So these spaces are very, very less in case of the solids. They are so tightly packed with each other. Okay, and the spaces between them is fixed since they are very closely packed with each other. So this arrangement of particles itself give them a definite shape. There are clear cut boundaries and you cannot compress them. See, compress means what? To apply force, right? So when we are applying force, there is no space between the particle where the another thing will get accommodated, or it cannot make a space because the space are itself very, very less. Since the spaces are very less, it means what? They have got higher force of attraction among the particles. Among the particle, the force of attraction is very high. So the intermolecular spaces or the interparticular spaces or voids, which is also called as, they are very less, and it is also telling us yes, they are having very high forces of attraction. See, the force of attraction is very high, that is why they are closely bound with each other. It is just as making in the case of a laddu. Okay, when we are making a laddu, what is there, that if we are putting the right amount of the ghee, we can bind them. Okay, we can give it a proper shape. So those factors are same here applicable. You can see that the force of attraction is so high among the particles that they bind it together to give a proper shape or a definite shape to the object here. So there are very high or the strong force of attraction is there. Now if you see the density is what? Density is basically, if we go by definition, density is mass per unit volume. That is how closely they are packed. How closely they are packed. So if you see the density formula, it is mass upon volume, right? So density, like, it is a tight arrangement of the particle in a space, or you can say that how they are tightly packed in a space. So in the case of the solid, you are seeing that in this space the particles are very closely packed. So of course the density is very high. Density is very high in case of solid because they are very tightly packed. Now, negligible kinetic energy. Kinetic energy, we are talking here in the terms of motion, which we have understood that yes, the particles of the matter are in motion. So here also they can move or they are in motion. But see, again, the particles are very closely packed. They are very closely packed. So the motion is not high or it is not random even. They only vibrate at their own position like this, like this. They will keep on vibrating because they cannot go out. Why? Because they are having strong forces of attraction between them, and the intermolecular spaces or the interparticle spaces is very, very less. So they only vibrate at their position. So of course there is a motion, there is a kinetic energy, but the level is very, very low in case of solid. Now let us move towards the liquid state. In the liquid state of matter, they have got no fixed shape, but they have got a fixed volume. Now liquid state, common examples, if you see around us, you will say that it is water, one of the very common one. Then we are having the milk. Some of you can say tea, some of you can say honey is also there, right? So all these are water, cold drinks. All these are in liquid state. So we know that they are not having a fixed shape. Like for example, you take for example, here there is a jug which is in the shape of a pitcher. There is a glass, okay, which is quite having the slanting boundaries to it. There is a beaker like this, okay. There is a spoon here like this. Now, if you are going to pour water in them, water will take the shape of the container. For example, if we are putting water in this, it will take up the shape of the pitcher. If we are putting it here, it will take up the shape of the glass. If we are putting it here, it will take up the shape of the beaker. If we are putting water in this spoon, it will take the shape of the spoon. Okay, right? So, it has got no fixed shape. Liquid has got no fixed shape to it. You must have observed the cold drink bottles also. They come in various kind of packaging. Okay, so you know that they take up the shape of the container. Okay, juices come in the tetra pack, cold drink comes in a very curved bottle. There are cans also, so obviously they take up the shape of the container in which they are kept. But yes, they are having a fixed volume. Of course, when you are buying any kind of the juice, milk, or any kind of the cold drink, you always see that the volume is mentioned on the bottle, like for example 100 ml or 200 ml or 900 ml. Okay, like that. So of course they are having some fixed volume, that is they take up the volume. Now they are not rigid, they flow and change shape. Now we know from our previous topics that every matter is made up of particles. So obviously water will also be made up of particles. So suppose these are the particles of the water like this. Okay, now the water particles I'm saying here. Now if you are going to pour the water from a glass, okay, to a big container, okay, this is a container, and if you are going to pour water from a glass, okay, so what will happen? It will go like this, like few of the streams of the water will be touching the rim. Okay, few will be here and some stream of the water will be here, like that, isn't it clear? But suppose if you are throwing a ball, in the container, the ball will go at once. It will reach to the container. Okay, you will not be seeing that some of the ball is here and some is here. It will go and reach inside the container. But that is not the case of the liquid state, whether it is water, juice, or whatever. When you are pouring, you are seeing that some of it has already entered the container, some of it is still on its way, basically. So they are fluid in nature, that is called as they flow. There is a fluidity in their nature. They are not rigid because they don't have a definite shape. Okay, why they are not having a definite shape? When a liquid is observed under the microscope, you will be seeing that the particles are packed together, but there are spaces between them. Like this. These spaces are of course fixed. Okay, and they have got much more spaces between the particle as compared to the solid. And since they are having spaces between them, it means what? They have got intermolecular force. Of course, every type of matter will have intermolecular force of attraction among its particle, but the level will keep on differing. In the case of solid, it was so high that it tightly packed the particles together. But in the physical state, we are seeing that more space is there between the particles. If the space is more as compared to the solid, so the force of attraction will be less as compared to the solid. Now see, this force of attraction between the particle is less here, so that is why the particles are not tightly packed, and that is why it is giving the liquid state its fluidity. Okay, so the particles have got large intermolecular spaces as compared to the solids, and the force of attraction is weak as compared to the solid. Now if the force of attraction is weak, so the particles can move. They can move little bit here and there. The particles can move here a little bit in case of the liquid, here and there, as compared to the solids, as compared to the solid state particles. Why? Because they have got more spaces and the intermolecular force of attraction is also weak, right? So in this way we see that they can move, but the distance between the particle always remain fixed also. Between the particles, the space between the particles remain fixed. Now let us go to the gaseous and yeah, density, of course they have got less than density as compared to the solid state. For example, I'll give an example. Suppose this is a cube, okay, and this is another cube of the same size, everything is same, okay. Now if in this case the particles are tightly packed in this cube in the same volume, you are having 100 particles, and in the same volume if you are having 75 particles packed, okay, in this there are 75 particles which are packed, okay. The cube are of same length, breadth and height, they are having the same volume, but in one you are seeing that 100 particles are packed, and another you are able to keep only 75 particles. Why? Because here there are spaces between the particles. So this is the liquid state and this is the solid state where they are tightly packed. So more number of particles are compactly arranged, so obviously the density in case of the solid is high, but in case of the liquid the density is low as compared to the solid. Why? Again, in the same volume less number of the particles are packed because there is space among the particles, okay. Now let us go to the third state, that is the gaseous state. In the gaseous state of matter, they have got no fixed shape, they have got no fixed volume. For example, if we are filling the air inside a balloon and balloon is of round shape, it takes the shape of the balloon, it will come out round in shape, right? Okay, if you are filling the air inside the heart shaped balloon, it will take up the shape of the heart shaped balloon, right? And nowadays you know that there are um, balloons in which the happy birthday is written, so they take up the shape of the alphabet there, like H8PPY and so on. So obviously they have got no fixed shape, and they have also not got any fixed volume. They take up the shape, like they fill the container completely always. For example, if we transfer a gas from small container, if you are transferring a gas from the small container, okay, to a big container, transfer it to a big container, you will be seeing that the gas will occupy the whole of the big container, okay, the same gas. So it has got no fixed volume to it also. They are not rigid, they flow and change shape just like the liquid. Why? Because the particles are loosely packed. In this case, in the case of the gases, the particles are very much away from each other and they have got very large intermolecular spaces between them. Since they have got large intermolecular spaces between them, it tells us that the force of attraction is very weak. Among the particle, the force of attraction is weak. That is why they are away from each other. If the force of attraction is high, they will try to come together or they will be together itself, right? But that is not the case of the gas. In gas we see that they move here and there randomly, okay. It means that they have got large spaces among its particle, and obviously the force of attraction is also very weak between the particles. That is why they take up any shape very fast, or you can say that they are not having a definite volume to it because they move here and there randomly. So they have got large intermolecular spaces between them. As compared to the solids and liquid, the force of attraction between the particle is very weak as compared to the solids and liquid. And as you know that they are in random motion here and there, so obviously they will be having the highest kinetic energy or the motion in the particles, right? And the density will be least in this case. In this case the density will be least. Why? Because they have got so much of the space among the particles that in the same volume you won't be able to fit, okay, more than 5 or 6 particles itself, right? In our previous example I'm saying. So obviously the density is least in this case. Now let us take a very quick recap of the physical states of matter, solid, liquid and gas through a chart. Now here in this case, as you are seeing that we are discussing very simple characteristics of the solid, liquid and the gaseous state. Mass, of course the solids have got a definite mass to them, liquids have got a definite mass to them, and gases also having. Okay. Now shape, they have got a definite shape. They acquires, the spelling of acquire is wrong in both the cases. The shape of the container, here also the gas takes up the shape of the container. Volume is definite, here also it is definite, but in case of the gas the volume is not definite. Spaces among particles, you know that they are very tightly packed like this. Okay, here they are loosely packed, meaning to say they are having spaces among its particle like this. Okay, so the space is more as compared to the solid, and in this case they are very far away from each other like this. Okay, so the kinetic energy, since they are tightly packed, so obviously it will be least. Here there are some spaces between the particles, so they can have an option of the movement more as compared to the solid state, so higher as compared to the solid but less as compared to the gases, because the force of attraction among the particle is least, so that is why they can move to a greater distance here. So it is the interparticular force of attraction, here it is strongest, here it is weak, and here it is negligible. Compressibility, here it is negligible. Here you can compress water because the particles have got spaces between them, and they are highly compressible in case of gases because the particle have got huge spaces among its particle. Fluidity, it is not possible in case of solid because the particles are tightly packed. Then you can see in case of liquid and the gases, they can flow because the particles are little bit loosely packed and the force of attraction is also weak. Rigidity, solids are very rigid but liquid are less rigid, and in case of gases there is no point of rigidity even. Then diffusion, that is mixing or the movement. Now see, diffusion comes from the kinetic energy basically. Okay, diffusion means, diffusion is actually the movement of particle from the high region towards the low region. Now here you are seeing that the particles are very less in motion, that is they vibrate at their own position in case of the solids. So obviously diffusion we will not be able to see, that is why slow or negligible here, but it is more in case of the liquids as compared to the solid, and it is very high or fastest in case of the gases because diffusion is directly related to the kinetic energy. If something is in motion, obviously the particles will move from the region of high concentration to the region of low concentration. In the solid, they are just vibrating at their own position, so there is no point of diffusion there. But in case of the liquid, they move more as compared to the solid. The particles move as compared to the solid. So that is why we see diffusion is there in case of the liquid, and it is highest in the case of gases because the particles are always in motion there. Okay, density we have already discussed, it is highest in case of the solid, less in case of the liquid as compared to the solid, but it is least in case of the gases. Right, you can also take up solid, liquid and gaseous state. For example, in the terms of the particle, like when the teacher is there in the class, you all sit at your places, you don't move. Okay, right, clear, you all are tightly packed in the class. Once the teacher leaves, after finishing the period, once the teacher leaves, you come in motion little bit but inside the class, that is the liquid state. But once the school gets over, you all come in the gaseous state, you start moving here and there. Okay, right, so this is all about the physical state of matter, that is a solid, liquid and the gaseous state. Basic characteristics we have discussed. In my next session I will be moving ahead in the chapter. If you are liking the sessions, kindly subscribe and share the link among your friends and family. See you in my next session. Bye bye.